What are the best Linux kernel optimization tips? Imagine your computer running faster, smoother, and more efficiently than ever before. That's what optimizing the Linux kernel can do for your system. Today, we're going to look at some practical ways to tune the core of your Linux operating system. The Linux kernel is the heart of any Linux distribution, managing hardware, processes, and system resources. Customizing it can make a big difference, especially if you're running demanding workloads or want to squeeze out every bit of performance. First, consider compiling a custom kernel. This means downloading the latest stable source code from the official Linux kernel repository. You'll need development tools like compilers and configuration utilities. Use these tools to enable only the drivers and features your hardware needs. Disabling unnecessary modules reduces system bloat and can lower latency. When you compile, do it using multiple CPU cores to speed up the process. Once done, install the new kernel and update your bootloader so your system boots into it. This approach is great for gaming, real-time processing, or high-performance tasks because it removes unnecessary code that can slow things down. Next, tuning kernel parameters at boot time can help optimize startup and system behavior. You can add options like quiet mode to reduce boot messages or set filesystem, mounting modes to read-only or read-write depending on your needs. Disabling video drivers during boot with options like namode set can also improve boot times and hardware compatibility. These adjustments make your system start faster and behave more predictably. At runtime, you can tweak kernel settings related to networking, memory, and process scheduling. For example, increasing buffer sizes and backlog queues can reduce network latency and improve throughput. Adjusting memory management parameters helps optimize cache usage and can cut down on swap activity, keeping your system responsive. Fine-tuning process scheduling ensures critical tasks get priority, which is especially useful for servers or real-time applications. File system parameters can also be optimized for faster disk input and output, especially if you work with large files or databases. Optimizing file system performance involves choosing the right file system for your workload. File systems like BTRFS support specific features that can boost read and write speeds when configured properly. Mount options and caching strategies can further reduce latency and improve overall disk performance. Power management is another area to consider. Setting CPU scaling governors to performance mode keeps your processor running at maximum frequency during heavy tasks. If power-saving features interfere with performance, disabling them temporarily can give you a boost, especially on desktops or servers. Keeping your kernel up to date is essential for security and performance. Use your Linux distribution's update tools to automatically install patches and new versions. If you use custom kernels or run virtual machines or containers, monitor updates carefully to avoid compatibility issues. Finally, if your workload involves containers or real-time processing, you can tune kernel parameters specifically for those use cases. For containers, this might mean adjusting networking and process scheduling settings. For real-time systems, enabling specific kernel features and disabling latency-inducing options can make your system more responsive. In summary, the best way to optimize your Linux kernel is to tailor it to your hardware and workload. Compile a custom kernel, tune parameters at boot and runtime, optimize your file system and CPU settings, and keep everything updated. These steps help your system run faster, more stable, and more responsive for whatever tasks you throw at it.